Hello students, by this video let us study about the properties of alum. So, while considering the properties, alum is white crystalline solid. It is crystalline solid it is, okay, white in color, okay. Now this alum is soluble in water, that means when you put it into water, it undergoes solubilization, okay, it is soluble in water, completely dissolved in water, but in alcohol it is insoluble, that means it will not dissolve in alcohol. Alum will dissolve only in water. Fine. Now this alum, when it is dissolved in water, it becomes aqueous solution. Aqua means water, it becomes aqueous solution. Now this aqueous solution is acidic in nature. It is acidic in nature. Now what is the reason for its acidity? Yes, because the aluminum sulfate which is present in alum, they will undergo hydrolysis. So for that reason only, this alum aqueous solution or aqueous solution of alum is acidic in nature. Fine. Now when we burn this alum or when we heat this alum, so at a temperature of 365 Kelvin, alum starts melting. It will slowly start to melt because it is solid, crystalline it is. Yes, so it slowly melts at this temperature, that is 365 Kelvin on heating. Now, when we increase the temperature further to 475 Kelvin or 500 Kelvin, what happens to the alum? The water molecule, how many water molecules? 24 water molecules present in alum. All these 24 water molecules is lost. Okay, so how is it lost? This alum, it will swell up. It will swell up by losing all the water molecules. It will swell up. Its mass increases. It becomes a bigger size in mass. So that swollen mass is called as burnt alum. So this burnt alum is another important 2-mark question. Yes. So what is burnt alum? So at 475 Kelvin or 500 Kelvin on heating, the alum loses its water molecules. How many water molecules? 24 water molecules and swells up. This swollen mass is called as burnt alum. Understanding? Now let us look at the reaction of how the burnt alum is formed. So here you can see K2SO4, Al2SO4 thrice with 24 water molecule, that is your alum. On heating to 475 Kelvin or 500 Kelvin, all the water molecule is lost. Yes, so this too is retained as it is, only the water molecule is lost, that is burnt alum is formed. So that burnt alum formula is K2SO4, Al2SO4 thrice. Okay, and 24 water molecule is lost. Okay, now let us balance this equation. Yes, so here K2SO4 as it is, Al2SO4 is also as it is, 24 water molecule on the left hand side, on the right hand side also 24 water molecule, so it is balanced. So we need not consider about it. Now in the next step what happens, this burnt alum we take, again we increase the temperature and we heat it. We heat it to high temperature, make it red hot, So this burnt alum, when we make it red hot, what happens to the burnt alum? It undergoes decomposition. Decomposition is splitting. So decomposition takes place and K2SO4 is formed, potassium sulfate, aluminium oxide or alumina and sulfur trioxide is obtained. oxygen atoms are. So now it is balanced. So to balance, if you put here 3 near to sulfur trioxide, it gets balanced. Okay. So from this reaction, we understand that burnt alum, when it is heated to red hot, decomposition of burnt alum takes place and you get potassium sulfate, K2SO4 is potassium sulfate, Al2O3, that is your alumina. So hope you remember what is alumina. Yes, alumina, it is also called as the ore oxide like Al2O3. So alumina and SO3. SO3 is sulfur trioxide. Sulfur trioxide. Yes, so that's it. So another property of this alum is alum also combined with ammonium hydroxide to form aluminium hydroxide. So let us see that reaction. Potash alum is treated with ammonium hydroxide to give aluminium hydroxide. So this is another property of alum. So whenever alum, that is the potash alum, react with ammonium hydroxide, the product what we get is aluminium hydroxide. So now we see how the reaction takes place. So this is potash alum, react with ammonium hydroxide, NH4OH. What happens during the reaction? Potassium sulfate is retained as it is, no change in that. Even the water molecule is also retained as it is. But aluminium sulfate is getting converted into aluminium hydroxide. So the aluminium combined with the hydroxyl group of ammonium hydroxide and it forms aluminium hydroxide. Got it? So aluminium sulfate, aluminium only will combine with the hydroxyl group of the ammonium hydroxide and it forms aluminium hydroxide. Okay. Likewise, NH4, ammonium hydroxide combined with the sulfate of aluminium sulfate to form ammonium sulfate. Got it? Yes. So likewise, potassium sulfate, as I said, it is retained. 24 water molecules also retained. All the aluminium sulfate is getting converted into aluminium hydroxide. Yes, and ammonium sulfate. Got it? So here sulfate combines with NH4 and forms NH4 to NH4 to SO4 and aluminium Al2 combined with OH and form AlOH thrice. Okay, now let us balance this reaction. So K2SO4 on the left hand side and the right hand side, it is the same, no change in that, so we need not touch to it. Now 24 water molecules on the left hand side, on the right hand side also 24 water molecules, so we need not bother about that. Now here we have to bother only about aluminium and sulfate and ammonium hydroxide. So here 2 aluminium is there, here on the right hand side only 1 aluminium, so I just put here 2 to balance. Now 2 aluminium, now aluminium is balanced. Okay, now so when aluminium is balanced, how many hydroxyl groups are there? 6 hydroxyl groups are there. Okay, 6 OH group is there. Okay, so 2 into 3, 6 OH. Whereas here only 1 OH. So what will I do? I will put here 6. So 6 OH, now that is also balanced. Okay, now when I put here 6, how many ammonium? 6 ammonium, 6 NH4. Whereas here only 2 NH4. Yes, so I put here 3. So 3 2s are 6. So 6 NH4 is balanced, both the sides. Okay, now sulfate, 3 sulfate is there on the right hand side. On the left hand side also 3 sulfate is there, so it's balanced. Okay, so this is the reaction of potash alum with ammonium hydroxide. The product you get is aluminium hydroxide. Yes, so potash alum react with 6 molecules of ammonium hydroxide to give potassium sulfate and 2 molecules of aluminium hydroxide and 3 molecules of ammonium sulfate and 24 molecules. Right? So hope you understood. So this is also important property of alum is very important, frequently asked question in question papers. Then what is the formula for potash alum? Then what happens when potash alum is treated with ammonium hydroxide? So also another 3 mark question, important questions which you can expect from this topic. Yes, so hope you understood. Thank you.